Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. As we continue with our organic reactions, and in this lesson we're looking at esterification. In the previous reaction lesson we looked at oxidation of alkanes, and I will encourage you to grab hold of it. And also guys, if this is your first time coming in contact with this channel, it means you have missed I think almost 15 or so videos, and it is because you're not subscribed. Subscribe so that you can get hold of all the other videos that will give you a complete guide in organic chemistry. So let's look at this one, the reactions in organic chemistry, and here we are looking at esterification, esters. So we're saying equation and reaction conditions for the formation of an ester, and the IUPAC names for reactant and products. So we're going to look at all that. Now first part is, what are the uses? Because they will ask you that. What are the uses of esters, or some they call esters? And esters are characterized by odors. One of their thing is that they are characterized by odors or aroma, that is a smell, sweet smelling, most of them, and are used in synthetic flavors. You can choose that. Uses: they are used in the making of perfumes, they are used in cosmetics, because there is also perfume in a cosmetic, as well as solvents, for example in paints. Whenever you are looking at solvents, I think there is one, is it butyl acetate is one of the common solvents. So look at this. This is an example where you find an ester in practice. Yogurts, or all these perfumes that you can think of, esters are the ones involved. So if esters are the ones involved, it's a very interesting part of chemistry. The question is, how do you form these esters? I think even in your grade 12 you're going to do an experiment that will actually show you how an ester is formed. If in your SPA there are esters that you're going to be doing, it is actually quite an interesting experiment that you guys can do. It says equation and reaction conditions for the formation of an ester. Esterification is a what? Very important statement. Listen to this. Esterification, which is the process of forming of an ester, is an acid catalyzed condensation reaction. Now what does this mean? An acid catalyzed condensation reaction. Number one, what does this acid catalyzed mean? To form an ester you need an acid, and the name of the acid is sulfuric acid. Sulfuric acid. So you need an acid which is H2SO4. You need this acid so that the reaction can occur quicker. Remember, a catalyst is a substance that alters the path of a reaction, or it speeds up the reaction without itself getting used at the end of the reaction. So it lowers the activation energy, all those things. So that is what is needed. Number one, sulfuric acid. Number two, it says it's a condensation reaction. What does condensation mean? It results in formation. Condensation meaning it results in formation of water, H2O. Those are very important. So what they say, what type of reaction is esterification? It's a condensation reaction. And what is a condensation reaction? It means that water is produced in that reaction. So what does it mean? Let's form this reaction. When you are forming an ester, you are going to combine carboxylic acid plus alcohol, and then you have got here H2SO4, and also you can add heat. So these are the conditions. You need what? H2SO4. Remember, it's not part of the reaction. H2SO4, it's in the presence of, and then you've got what? You've got an ester plus what? Plus water. Remember, it's a condensation reaction. You need to form the ester and the water. The condensation part is the water there. Let's make a simple example of an esterification reaction. Suppose we have a carboxylic acid with 3 carbons, propanoic acid. So if I say you've got propanoic acid, it's better when you're doing the structures here. Propanoic acid, remember, is how many carbons? 1, 2, 3. Now I want you to pay attention on how you form an ester. So this is that propanoic acid. Remember the functional groups, O, H. You need to know that. The functional groups there. So there is that plus what? Plus, for the carboxylic acid, I said this is propanoic acid. Alright. Plus alcohol. Let's choose any alcohol. Let's choose ethanol. Now, how do you write ethanol? Let me change it and make it like this. Ethanol is 1, 2. This is ethanol. Okay. Let's say we are reacting with that ethanol. Remember, it's OH. And then while we are reacting these two, I needed to give it space. Let me not crowd it like this. So this is ethanol. So when these two are reacting, now what do we form? That's where the important part is. Now we are going to form an ester, but I want to show you how it is best for you. How do you put these equations together so that you can see what is happening? So what I will encourage you to do when it comes to an alcohol, I want you to I wish this will rotate like this. You see what I wanted to do? I wanted this to rotate like this, right? So that the OH is on the other side. But I'm going to rewrite it like this. So it's a matter of rotating it. But when I rotate it, it will be like this properly. Remember, it's H. Let me use the same. It's H, O, C, H, H, C, H, H, and H. This is still the alcohol. We call this ethanol. Now we are saying this propanoic acid, which is carboxylic acid, plus the alcohol ethanol, and then we said what is the reaction condition? It's H2SO4, and then also you might need heat. These are the reaction conditions. Now this is concentrated, right? It's concentrated sulfuric acid. This is the reaction condition. So what is it going to produce? Let me make the arrow large. What is it going to produce? It is going to give us what? It is going to give us an ester. Now look where the ester is coming from. The OH, you cut it there. Are you seeing that? And the carboxylic acid, you cut it there. This is where we are going to cut it from. Are you with me? So if I can cut it like that, and then I bring these two together, I'm going to erase this, but I'll bring it back. Look at this. You see, this is the water part. I'll show you where the water comes from, and then I will take this guy and bring it closer. You see that? And then that becomes the answer. That becomes the what? The ester. And then I will give the name of that ester at the end. But that is exactly what you do. You take out the water, you bring the bond whereby there is a bond that is formed like that. So let's do it properly. So what we are saying is you are going to form in here the C, H, 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 C, H. This is from the propanoic side. O. Now look, you have got what? That you have got O, then you have got C, H, C, H, 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 and H. So I want you to see how this became. I hope you are able to see that. Then you say plus. Remember, they said structural formula, so I always want you to be careful there. You can write your water, you can put it like this. Still fine. Leave it like that. Don't say H2O. Avoid this part. Leave it like that. Now, what is the name of this? Remember, when you're naming, you start with what? You start with the alcohol part. So the alcohol, it comes from ethanol, so it becomes ethyl, and then propanoic acid becomes propanoate. Propanoate. Just revisit the previous lesson where we did this esterification, esters, IUPAC naming of esters. You will get that. Are you with me? So that's why here it says reaction conditions and the formation of an ester. So when you're looking at the reaction conditions, the structural formulas, the IUPAC names, and the products that are formed, that is what they mean when they're saying you are forming an ester. The key part, guys, it is this. Remember, you are cutting the ethanol is cutting at OH and the carboxylic is at H. Hence, in the previous lesson, they sometimes ask you, they will give you this, whereby they say you are given this ester like this. Let me try to grab as much as I can. They can say you are given this ester. Let me take it down. Whatever is missing, I'm gonna fill it up. They'll say you are given this ester, and then they ask you which one is the alcohol component and which one is the what? Is the carboxylic acid, and name them. So remember where we cut it from, the OH. You see, we cut the OH here. So even you come here and you're going to cut it just there. Are you with me? And then this side belongs to the what? Carboxylic, and this side belongs to the what? To the alcohol. See that you can go backwards, and then when they ask you about the carboxylic acid, it's simpler. Now you just write that. It's simpler. It's a matter of going backwards. See, back, and then COOH, and then plus. In here, remember, we cut the OH, the HO. So the HO, and then we do that. That's what we cut for the alcohol. If it's confusing you, you can take this one, this side, to say this was the hydrogen, this is the OH. Some are used in this version. Still correct, whatever case. So this is the formation, guys, of an ester. Don't forget, it's a condensation reaction. Water is produced. You need not to forget this product, H. Don't write it as H2O. It's better to write it as, it's better like this. Some they write it like this. Anyway, but you must show the structure of water. Don't be tempted to write it as a molecular formula. Now let's look at this question. It can give us a bit of an idea here. It says draw the structure and the formula of the following reactions. Ethanoic acid reacts with methanol in the presence of heat and sulfuric acid as a catalyst. So ethanoic acid, so you do this. Let's get ethanoic acid, which is 1, 2 for ethane, right? That's ethanoic acid comes from ethane as the primary. The primary, remember, is 2 carbons. So ethanoic acid meaning ethane. It means 2 carbons. Ethanoic acid plus, what do you have? Plus methanol. Methane is 1 carbon. So methanol, very careful now, is an alcohol. So you say C. So you could have said like this, because it's just 1 alcohol with 1 carbon. You just do this. In proper form, it is like this. This is methanol. But as I said, to avoid you asking yourself which one will combine with what, so you twist it around to say I've got the H, the O. You must get used to this. Hydrogen hydrogen. You must get comfortable with this. And then with the alcohol, you just do with your pencil. You know that if I cut here, you know, you'll be doing with your pencil there, because you don't need to show this. This is where the water comes from. And then in here, if you have space, you'll continue like this. And then you're going to say H2SO4, or you can even write concentrated. It says conc means concentrated, concentrated H2SO4, and you hit. These are the reaction conditions that you need. Don't forget, they will ask you that. And then from there, what do you have? You have got now your ester, which is C. Okay, can I use a different pen? Yeah, if you allow me, let me do that. So this is the final product of the ester now. O, C, H, H, and H, and then plus O, H, and H. Now it says ethanoic acid reacts with this in the presence of this as a catalyst. So it says what? Draw the structure and formula. Draw the structure and formula of the following reactions. So these are the structures and the formula of the products. You see, draw the structure and formula of the following reactions. I don't know the formula, but here it's C2 H1234 H4O2 plus C1234. Am I right? C1234O, and then you get what? You get C123 C3 H123456, and then O2 plus H2O. Are you seeing that? That is the actual reaction in a way. So you're saying C2 H4O2 plus C4O, then you get C3 H6O2 plus H2O. You can balance it, check it. How many in this case, how many? It's I think I did wrong there. C, it's C, this is wrong here. It's C H4O. I must correct that. So this is C, because I'm seeing that it's not balancing now. CH4O. What does it mean? Carbons, there are 3. It's 3 carbons. Hydrogen, there are 6. This is 4, 8 on the other side, 6, 7, 8, and oxygen, there are 3. Oxygen, there are 2, 3. So it's still fine. It maintains that. So that is that. That's the formation of an ester. The reaction in which an alcohol, number 2 now. Number 2, the reaction in which an alcohol reacts with a carboxylic acid to form the products ethyl butanoate and water. Interesting one. So they gave us the product here, ethyl butanoate. So we want to find out the reaction. So let's start from the end. What is ethyl butanoate? Ethyl is 1, 2, that's the ethyl, the alcohol part. Remember, the alcohol, they cut it there, and then butanoate, they put that oxygen, you put that, butanoate. It's butane, 1, 2, 3, 4, because butane is 4 carbons. Are you seeing that? You see how this is coming. So this is what ethyl butanoate. So I'm coming from the end. This is ethyl butanoate. Ethyl butanoate. Now the question is the reaction. They're giving us the reaction in which they draw the structure and formula. So we have to go back now. Where did it come from? It came from the alcohol. So it's still fine. I can start with the alcohol to say the alcohol was the H, C, H, H, the single bond, it mustn't look like a double bond there. And then we've got C H H and then O H. Now remember where it's cut here, that's where the OH, and then plus the carboxylic acid. You see I've got the H, the O, the C, double bond O, and then 2, 3, 4, and then you do that. You see that? And remember here they said plus water. In here, so that's what you're having. And then for this reaction, you're coming down here where you're saying it's concentrated H2SO4, and then you also need what? You also need heat. That is why they formed ethyl butanoate. So what is the alcohol? The alcohol is ethanol plus, and then butanoate is butanoic acid. Butanoic acid. So ethanol, that's why it's ethyl butanoate, butanoic acid. You get ethyl butanoate. So guys, this is the reaction of what? Of esterification. And now we've come to the end of this lesson. In the next part, we're looking at more reaction conditions. Very important section. What are these? Addition reactions, and we are looking at addition reactions of alkenes. How do we move from this picture on the left hand side to the picture on the right hand side? An important reaction. Now this is addition reactions, and there's quite a lot of addition reactions. You can think of hydrogenation, halogenation, hydrohalogenation, and I think the other one is hydration. So you need to grab hold of the next lesson. Definitely. We've come to the end of our lesson. Thank you.